Hey everybody, in this example we'll be simplifying the following trig identity, or I keep saying identity, I mean expression, but we'll be using some fundamental identities to do so. So here what we have is we have 1 over cosine squared theta minus 1 over cotangent squared theta. And at first glance it could be a little awkward and confusing, but reminiscent of Pythagorean identities, and that's because we can use Pythagorean identity to work it out, but we're also going to be using the reciprocal identities to get started. So just as a little appetizer, we are going to basically take care of these trig expressions in our denominators and get them up in the numerator, and then once they're in that nice setup, we will probably recognize them as a familiar Pythagorean identity. So let's go ahead and get started on this example. So like I said, first thing we're going to do is we're going to bring everything from our denominators up. We're going to be referencing our reciprocal identities. So cosine in the denominator, or cosine on bottom, is the same as what? Secant on top, or secant in the numerator. That means when it's squared, it's just the product of two of these situations, so we can do the same for just secant as well. I know that the square rule is important when it comes to Pythagorean identities, but when we have just an expression without any plus or minus, it's very easy to just square everything and keep it true. If you square a sum or a difference, you have to expand with FOIL or distribution, and that's why the Pythagorean identity is true squared, but not true without it. Food for thought. So what am I going to rewrite over here? I'm going to start off with secant squared theta minus. Now, if you know your Pythagorean identities very well, you're probably thinking like, oh, okay, either this is going to turn into a 1 or it's going to have something to do with tangent. And if you recognize that this will, in fact, have something to do with tangent, because tangent, as a reciprocal, the reciprocal of tangent is equal to cotangent. And they're really reciprocals of each other. So that's their relationship right there. That means that this can be replaced with tan squared theta. So cotan on bottom equals tan on top. All right. Now, do you know your Pythagorean identities? Well, I hope so, because I hope your teacher has been pressuring you to memorize them. So here, my flashcard, what if we divide sine squared theta plus cosine squared theta equals 1 on both sides by cosine squared theta? What will happen? This is what we should know and be able to do and write on top of our paper anytime we have to do any simplifying of trig expressions or verifying trig identities. And that, in fact, will give you this cutie pie right over here. That being said, can we bring things around so that we're looking at secant squared theta minus tan squared theta? Well, if I subtract tan squared theta to this side, what do I get? If you said 1, you're absolutely amazing, and that's all there is to it. Now let's pretend you like straight up only memorize the Pythagorean identity as is, and you're like, nope, I can't rearrange it. No idea what the heck you're talking about. Well, there's a way around that. Secant squared theta apparently equals tan squared theta plus 1. So secant squared theta is equal to tan squared theta plus 1. Sure. So I just replaced those right there. This one, minus tan squared theta, I'm just going to leave it as is. We don't have to change everything. Just because you're changing one thing in an expression doesn't mean you have to change everything. I'm just going to change secant squared. Do I need parentheses right now? No. When do you need them? When it's multiplication, which it's not, and when you have a minus sign, subtraction, in front of the parentheses, and we do not. So we don't really need them. I know I'm being extra. I'm just trying to make you smarter. Sorry. Watch it in double speed if you find it annoying. But tan squared theta minus tan squared theta, that cancels one another out, turns to 0, and final conclusion is 1. So this turned into this, which I turned into this, turned into that, turned into that. Could I have gone from this immediately to 1? Sure. But in case you have some beef with rearranging Pythagorean identities, well, then do it this way. All right. So that was a little use of our reciprocals and a little use of Pythagorean identities. Hope you found that helpful. Hopefully you feel smarter right now. If you followed, understood, got it right on your own, can get it right on your own, let me know with a thumbs up. If you are riding the struggle bus, let me know with the thumbs down. All right. And click through to the next video or go to the playlist so that you can continue to make your brain better. Adios.